Night. Europe. Late autumn 1944. A cold rain falls over the shattered countryside of northern France. The sky is a sheet of gray, lit only by the dull flashes of distant artillery. Along the banks of the Meuse River, American convoys stand motionless, engines idling, headlights blacked out, tires sunk deep into the mud. Ahead of them, where a bridge once stood, there is nothing but twisted steel and a swirling torrent of brown water. German shells had found their mark that afternoon, collapsing the last crossing for miles. To the enemy, it meant victory, another delay, another night the Americans would spend trapped behind the river. Somewhere in the darkness, German commanders smirked, certain that no army could replace such a bridge before morning. But deep in the night, a faint metallic rhythm begins to echo. Hammer strikes, chain clinks, orders shouted under breath. Dozens of engineers, soaked, freezing, exhausted, work by the dim light of covered lamps. Steel panels slide together, bolts tighten. The framework rises inch by inch. By dawn, the rain has stopped. And to the astonishment of German patrols across the river, a new bridge spans the Meuse, carrying Sherman tanks toward them. The story of the Bailey Bridge begins long before that cold night in 1944, before the Allied advance through France, before D-Day, even before America entered the war. From the first campaigns of 1939 and 1940, German engineers had weaponized destruction. Wherever the Wehrmacht moved, they left behind rivers stripped of crossings, railways shattered, and bridges reduced to rubble. The Blitzkrieg was not only about tanks and planes, it was about speed and the denial of speed to the enemy. In France, the Low Countries, and later across the Soviet Union, German forces made a science of collapse. They destroyed infrastructure faster than anyone could rebuild it. When the Allies finally began to push back, they discovered a simple truth of modern war. Victory depended not just on firepower, but on mobility. Rivers, those ancient natural barriers, became the greatest enemy of all. In 1943, a U.S. Army staff officer wrote, "An army can only fight as far as it can drive its trucks." But across Europe, the bridges had vanished. During the early campaigns in North Africa and Italy, the Allied armies learned this lesson in the harshest possible way. Convoys stretched for miles behind broken crossings, engineers wading through rivers under fire, attempting to lash together makeshift pontoons from boats, barrels, or timber. Rain and mud made these improvised structures unstable. Heavy vehicles, Shermans, half-tracks, supply trucks, could rarely cross without incident. Sometimes entire bridges collapsed mid-convoy, plunging men and machines into the current below. Each lost bridge meant hours, sometimes days of paralysis. Each delay meant the Germans could regroup, retreat, or counterattack. In Tunisia, during the winter of 1942–43, British and American engineers struggled to keep pace with their own advances. They built dozens of temporary crossings, most of them inadequate, few of them lasting more than a week. The problem was universal. Rivers could stop divisions as surely as an enemy army. The Allied High Command recognized that no amount of bravery could overcome physics. They needed a bridge that could be built fast, strong enough for tanks, and light enough for men to carry in pieces. Yet, such a design did not exist. Not yet. It would come not from a general or a commander, but from an unassuming British civil servant with an engineer's imagination and a soldier's sense of urgency. Donald Bailey worked quietly in Britain's War Office, specializing in military engineering solutions. Before the war, he had designed model bridges for fun, testing them in his garden. When the war began, he turned that curiosity into a desperate necessity. His idea was radical in its simplicity: a bridge made entirely of small, prefabricated steel panels that could be carried in trucks, assembled by hand, and launched across almost any gap. No cranes, no rivets, no complex machinery. In 1940, Bailey presented his prototype, a series of rectangular steel trusses designed to interlock like a giant mechanoset. Each panel could be lifted by 6 men. Combined in layers, they could carry anything from infantry to fully loaded tanks. The genius was modularity. The same parts could build a bridge 20 feet long or 200, depending on the need. The War Office approved it almost immediately, but no one yet grasped how revolutionary it would become. In the coming years, the Bailey Bridge would spread across continents, from the deserts of North Africa to the mountains of Italy, and eventually into the heart of occupied Europe. It was not glamorous. It had no guns, no armor, no roar of vengeance. Yet it would carry the weight of entire armies. And when America entered the war, it would take Bailey's invention and turn it into an industrial marvel, mass-producing thousands of sections, ready to move with the advancing front. But before the Americans could adopt it, they first had to understand just how desperate the need had become. Because in the early months of 1944, as the Allies prepared for the invasion of Normandy, one question haunted every logistics officer. What good was liberation if you couldn't cross the rivers to reach it?
By early 1944, the success of the D-Day invasion depended on more than ships, aircraft, and infantry. It depended on an invisible army, the engineers who would follow the first wave ashore. Every plan, from Montgomery's crossings to Patton's dashes across France, hinged on one logistical truth. Once the Allies landed, every bridge in Normandy would be gone. German demolition teams had standing orders to destroy every crossing as they retreated, choking the advance in rivers and marshes. The Allies had to be faster. The answer lay in the design of one man, Donald Bailey, and the industrial power of another nation, the United States. The Bailey Bridge, first deployed by British forces in North Africa, had proven its worth. Soldiers called it a bridge in a box. It could be built anywhere, in daylight or darkness, under fire or rain. When American engineers saw it in action, they immediately recognized its potential. The U.S. Army Corps of Engineers worked with British experts to adapt the bridge to American production lines. Factories from Detroit to Pittsburgh began churning out Bailey components by the tens of thousands. Each bridge was not a single structure, but a system. Panels, 10-foot steel rectangles that formed the sides. Transoms and stringers, crosspieces and beams that locked together. Decking, wooden planks or steel sheets for the roadway. Every part could fit into a truck or trailer. A team of trained engineers could unload, assemble, and launch a 200-foot bridge in less than 12 hours. To a German commander, this speed was inconceivable. To the Allies, it became routine. The true power of the Bailey Bridge was its mobility. Unlike older military bridges that required cranes or barges, a Bailey could be pushed forward piece by piece, its nose extended over the gap until it reached the far bank. Then the entire structure slid into place. It didn't need anchors or scaffolding. It could span craters, canals, and rivers alike. By the spring of 1944, hundreds of Bailey sets had been stockpiled across southern England. Each major Allied unit, British, Canadian, or American, had its own engineering battalion trained to deploy them. These men drilled endlessly, memorizing the process by touch and timing. They learned to build under pressure, under enemy fire, and sometimes underwater.
When the invasion came, they followed close behind the first wave of infantry. On the beaches of Normandy, amid wreckage and chaos, engineers began assembling the first Bailey sections even before the fighting ended. Within days of the landings, they had rebuilt crossings over the Orne, the Veer, and countless smaller rivers, restoring traffic to the front. To the soldiers advancing inland, these bridges seemed to appear as if by magic, silent steel skeletons rising from the mud overnight. But to the men who built them, it was a race against time and exhaustion. Each completed span meant another breakthrough, another road reopened, another convoy pushing forward. The Bailey Bridge became the silent backbone of the Allied push across France. As General Eisenhower later said, "Without the Bailey Bridge, we could not have won the war." Its impact went beyond the battlefield. It reshaped the very nature of military logistics. The Germans, who once believed rivers could slow any army, now faced an opponent that could build faster than they could destroy. Wherever they blew up a bridge, a new one appeared within a night. By the end of 1944, the system was unstoppable. The Allies carried Bailey panels across Europe in endless convoys. Trucks full of steel trusses followed tanks as closely as ammunition trucks. Engineers were no longer just builders. They were combatants, moving with the spearhead of the advance. The Bailey had turned the laws of terrain against the Germans. Rivers no longer divided armies, they connected them. And soon, this unassuming structure would play a role in one of the fastest advances in modern military history, when generals like Patton and Montgomery began their race across the continent. But before that could happen, the world would have to see just how much one bridge could change the course of a war.
The Bailey Bridge was more than a structure of steel and bolts. It was a philosophy of war, a new way of thinking about movement, logistics, and time. To understand how it transformed the Allied campaign, we must look at it through several lenses: tactical, human, and psychological. Tactical angle: bridging under fire. In warfare, timing is everything. The Bailey Bridge gave the Allies something the Germans had never faced before: continuous momentum. Traditional military doctrine dictated that once a major river was reached, operations halted. Infantry secured the banks, engineers surveyed the site, and only then would a bridge be constructed. It could take days, sometimes weeks, before armored units could move forward again. The Bailey Bridge obliterated that limitation. At the tactical level, its genius was speed. Engineer battalions could roll up to a river within hours of capture, unload prefabricated sections, and begin assembly immediately. German artillery might still be firing across the water, but the bridge kept rising, panel by panel. The soldiers who built them called themselves bridge fires. They often worked with rifles slung over their backs, crouching as shells exploded nearby. They didn't dig trenches or return fire. Their weapon was precision, the steady rhythm of bolts and wrenches echoing through the smoke. Every completed span meant life or death for the units waiting behind. When General George S. Patton drove his Third Army across France, his engineers built dozens of Bailey bridges in record time. In August 1944, during the breakout from Normandy, Patton's units advanced over 400 miles in just a few weeks, a feat made possible only because Bailey bridges kept the supply lines unbroken. German intelligence reports were bewildered. In one dispatch, a Wehrmacht officer noted that the enemy advances as though the rivers have disappeared. In reality, they had not disappeared. They had been conquered by steel and ingenuity. The human angle: the silent builders. For the men who built these bridges, there was no glory, no medals, and rarely recognition. They worked in darkness, soaked in river water, carrying tons of steel on their shoulders while artillery flashed overhead. Many were not frontline soldiers, yet their work placed them closer to danger than most. A single misstep could send a panel crashing into the current or expose a crew to enemy fire. The Bailey Bridge demanded both muscle and discipline. Teams of 12 to 20 men performed each step with mechanical precision, connecting trusses, inserting pins, tightening bolts, rolling the bridge forward on rollers as it extended. One wrong move could twist the entire structure. Yet, despite exhaustion and chaos, the engineers developed an almost symphonic rhythm. Commands were shouted short and clear: panel up, pin in, launch forward. They built in freezing rain, in mud that swallowed boots, in darkness so complete that they worked by touch alone. There were no heroics, no charges, no cheering crowds, but just a quiet race against dawn. When the job was done and tanks thundered across the finished bridge, the engineers would be ordered to pack up and move to the next river. Their reward was the sound of metal creaking under the weight of armor, proof that their work had held. Among the Allied ranks, they earned a quiet respect. Infantrymen called them the ghosts of the riverbanks, appearing in the night and vanishing before sunrise, leaving behind miracles of steel. One British corporal later recalled, "We built under fire so often that the noise of shells became part of the hammer rhythm." They weren't fighting for fame or conquest. They were fighting for movement, for the idea that nothing, not even a river, could stop the Allied advance. Psychological angle: the German shock. To the German command, the speed of Allied bridging operations defied logic. In previous wars, rivers had been natural defenses, lines to regroup, recover, or counterattack from. But by 1944, that advantage was gone. Reports from German field units repeatedly mention unexpected crossings appearing overnight. Officers described entire columns of enemy armor suddenly materializing on the opposite bank, mere hours after a bridge was destroyed. They couldn't understand it. At first, the German engineers assumed the Allies had secretly stockpiled massive bridging equipment or pre-built structures. But reconnaissance photos revealed something different: dozens of small, modular sections assembled on site. The realization was demoralizing. Every demolition became meaningless. Each time a bridge was blown up, a new one appeared. The German retreat through France and Belgium became a nightmare of futility. They could destroy everything behind them, but they couldn't slow the Allied pace. In psychological terms, the Bailey Bridge eroded the very concept of defensive geography. Rivers no longer provided security. They were just temporary lines on a map. For commanders like Rundstedt and Model, who relied on delaying tactics, this was devastating. By the time they ordered a withdrawal, Allied armor was already on their heels. One captured German report summarized the frustration bluntly: "Enemy bridges appear faster than we can plan their destruction." This relentless momentum had a cumulative effect, not only on the battlefield, but on morale. German soldiers began to feel hunted, cornered not just by superior firepower, but by an enemy that seemed able to defy terrain itself. For the Allies, it was more than a technical advantage. It was a psychological weapon. Because every time a Bailey Bridge rose from the water, it sent a message across the river: there is nowhere left to hide. And as the Allies pressed deeper into the heart of Europe, this message would become undeniable. From the Seine to the Rhine, where rivers once defined nations, the Bailey turned them into stepping stones.
4. Technological angle: the machine that defied limits. The Bailey Bridge was born from necessity, but it thrived on design perfection. Its strength came from geometry, not bulk. Each section was a lattice of steel triangles, a structure that distributed weight evenly, minimizing weak points. When joined side by side or stacked in layers, these panels formed a load-bearing skeleton that could carry tanks weighing over 70 tons. There was no welding, no heavy machinery, and no guesswork. Every component was standardized, interchangeable between British Canadian and American armies. A missing bolt in Normandy could be replaced by one from a crate shipped months earlier from Detroit. That interchangeability made the Bailey system not just a bridge, but an engineering ecosystem. It could be adapted on the fly, widened for dual lanes, reinforced with extra panels, or even launched from one bank without touching the water until it spanned the gap. Its modularity turned chaos into order. Engineers described it as mechanical poetry. They didn't need blueprints at every site. They had memorized the pattern, a universal rhythm of construction repeated thousands of times across Europe. And in a war of improvisation, where plans often disintegrated under fire, that consistency was a miracle. Even German engineers known for their meticulous craftsmanship grudgingly admired the Bailey. After the war, captured reports from the Wehrmacht's bridge units studied its structure in detail, calling it ingeniously simple and impossibly quick. In a sense, it embodied the Allied war effort itself, standardized, industrialized, and unstoppable. 5. Strategic angle. The bridge as a weapon of mobility. Strategy in modern warfare isn't just about where you fight, it's about how fast you can get there. The Bailey Bridge gave Allied commanders a weapon invisible on maps, but decisive on the ground: tempo. When the U.S. Third Army under General George S. Patton broke through the German lines after Operation Cobra in July 1944, they advanced faster than any force in modern history, sometimes 100 miles in a day. Behind every mile were the engineers and their Bailey bridges. As Patton's tanks rolled eastward, engineers raced ahead to secure crossings. Rivers that should have delayed them for days were crossed within hours. Every time a bridge was blown, new steel panels arrived on trucks within the same day from Detroit. That speed stunned even Allied planners. Patton later wrote in his diary, "Our engineers are magicians. The bridges appear as fast as we can drive to them." That speed had enormous consequences. It compressed the German timetable for defense. Commanders like Model and Rundstedt had no time to regroup. Defensive lines meant to hold for weeks crumbled in days because supply columns could move as fast as combat troops. In the British sector, Montgomery's 21st Army Group also relied heavily on Bailey crossings during the advance through Belgium and Holland. When the weather turned and rivers swelled, the Bailey allowed armored units to move where no army had moved before, over marshland, canals, and flooded plains. It wasn't just a bridge anymore. It was the bloodstream of Allied momentum. Without it, Operation Martin Garden, the race to the Rhine, and even the final drive into Germany would have been impossible to sustain. Every major crossing bore the signature of Bailey's invention, sometimes dozens of bridges side by side carrying columns of men, trucks, and armor in an unbroken flow. In logistics reports from 1945, the U.S. Army Corps of Engineers calculated that over 4,000 Bailey bridges were built by American units alone in Europe, totaling hundreds of miles of steel. Each one a silent victory. 6. Moral and symbolic angle. The bridge that united an army. War often glorifies destruction. The Bailey Bridge celebrated the opposite: creation. It represented the ingenuity and cooperation that defined the Allied cause. Unlike most wartime innovations, the Bailey Bridge wasn't a weapon designed to kill. It was designed to connect, to move men and machines toward liberation. Every span built brought food to civilians, supplies to front lines, and wounded soldiers back to safety. In a sense, the Bailey Bridge was a moral counterpoint to the war itself. It turned chaos into structure, despair into progress. For soldiers who crossed them, these bridges carried deep symbolism. To an infantryman trudging through the mud of France, stepping onto a newly built Bailey Bridge was stepping into the future, a promise that forward motion hadn't stopped. There are countless photographs of soldiers pausing mid-bridge, gazing at the engineers who built it. Many would later say that the sound of steel panels locking together became as familiar as the sound of gunfire, but far more hopeful. The Germans, who had once mocked the Allies' reliance on temporary bridges, came to fear them. Each new crossing meant another lost town, another retreat, another night of exhaustion. By late 1944, the Bailey Bridge had become more than just a structure. It was a statement of inevitability. Wherever it appeared, the war was already moving on. And soon that momentum would reach its greatest test, the massive crossings over the Seine and Rhine, where the full potential of the Bailey system would be unleashed. These rivers had once been barriers of empires. Now they would be conquered by men with wrenches and steel panels. By the time the sun rose over the Rhine in March 1945, even the most hardened German commanders understood the age of static defense was over.
August 1944. The Seine River, France. For centuries, this broad, winding river had been a line of defense, a barrier separating north and south, empire and invader. Now, as German forces retreated east after the collapse of their front in Normandy, it became their last hope to slow the Allied tide. Every crossing, every bridge was wired with explosives. As the Wehrmacht withdrew, they detonated them one by one, great arches of steel crashing into the water, choking the current with rubble and flame. They believed the river would buy them time. But the Allies were no longer an army that waited for bridges. As American and British units reached the western banks of the Seine, their advance stalled for only hours, not days. Orders came swiftly. Bridge it. The U.S. Army's 1,104th Engineer Combat Group, the veterans of Normandy, moved in under cover of darkness. Trucks arrived loaded with Bailey panels, transoms, decking, rollers, and the specialized launch noses. The site was carefully chosen, a wide bend near Mont Gassecourt, where the current was strong, but the banks were firm. The Germans across the far bank assumed it would take days to cross. By 10 p.m., the engineers were already working waist-deep in water. They drove pickets, laid the rollers, and began sliding the prefabricated panels forward. Spotters on the far side could only see the faint shimmer of covered lamps. Every clang of steel echoed across the river. Artillery shells began to fall, blind fire, more harassment than accuracy. The engineers didn't stop. By midnight, the bridge nose had reached midstream. It flexed and swayed, anchored only by human endurance. Men hauled ropes, hammered pins, tightened bolts, all while shells whistled overhead. At 3 a.m., the first segment touched the far bank. Cheers were stifled. There was no time for celebration. They locked it into place, laid the final decking, and checked every joint. At dawn, the first Sherman tank rolled across. The bridge groaned, but held. Within hours, convoys of jeeps, trucks, and artillery pieces streamed over. The Germans, watching from the opposite ridge, couldn't believe what they were seeing. They had blown every bridge for 50 miles, and yet before breakfast, an American army was crossing the Seine. It was the same story up and down the river. At Vernon, British engineers from the Royal Engineers 43rd Division built another Bailey under fire from snipers and mortars. They worked waist-deep in the current for 2 nights straight. At one point, a direct shell strike destroyed part of the nearly finished structure. They rebuilt it within hours. By August 27th, multiple Bailey bridges spanned the Seine, carrying entire divisions eastward. Montgomery's forces crossed in the north, Patton's in the south. The German retreat turned into chaos. Their defensive lines, anchored on the river, were shattered. The speed of the crossings stunned even the Allies themselves. The 249th Engineer Combat Battalion built a 720-foot double-double Bailey capable of carrying 70-ton loads in just 36 hours. Never before in modern warfare had a major river been crossed at that scale, that fast. What began as an engineering experiment in 1940 had now become a decisive instrument of victory. The Seine crossings opened the road to Paris, to Belgium, and ultimately to Germany. From that moment on, Allied advance was a continuous flow.
bridges rising behind the front like the veins of a living organism. Patton later wrote in his memoirs, "Our engineers can put up a bridge faster than the Germans can blow one." That was no exaggeration. German commanders who once dismissed Allied engineering as clumsy and slow now faced an enemy that built faster than they could retreat. In field reports, Wehrmacht officers described bridges appearing as if conjured. Some believed the Allies had hidden pre-built spans somewhere, airlifted into place. They simply could not accept the reality that human hands, guided by discipline and repetition, could create such speed. But the crossings of the Seine were only the beginning. Ahead lay the greatest river in Western Europe, the Rhine. To cross it meant breaking into Germany itself, shattering the last physical line between the Allies and Berlin. And the Bailey Bridge, once again, would lead the way.
March 1945. The Rhine River. It was more than a body of water. To the Germans, it was their final wall, the symbolic and physical barrier to invasion. The river was wide, fast, and lined with steep banks and heavy fortifications. Hitler had ordered it held to the last man. The Allies knew it wouldn't be easy. After months of brutal fighting across France and Belgium, they had reached the western edge of Germany. Now before them stretched a natural fortress over 400 yards wide in places, with every bridge mined or already destroyed. But the Allies had learned from the sign. They were ready. At Remagen on March 7th, the impossible happened. American troops from the 9th Armored Division stormed the Ludendorff Bridge, one of the last intact crossings over the Rhine before the Germans could destroy it. When word reached headquarters, disbelief turned to elation. Eisenhower immediately ordered, "Hold it at all costs." But the bridge was barely standing. Explosives had already damaged it, and German artillery was pounding it constantly. Engineers worked frantically, welding, bracing, replacing decking, under fire, with the entire span shaking from blasts. Dozens of men died keeping it open. Still, the traffic flowed. For 10 days, tanks and troops poured into Germany before the bridge finally collapsed into the Rhine. But by then, it no longer mattered. The foothold had been secured. Elsewhere along the front, the Bailey bridges took over. At Wesel, the British Second Army prepared for one of the largest amphibious and bridging operations of the war. The night sky on March 23rd turned to daylight as more than 3,000 Allied guns opened fire in a thunderous barrage. It was the signal. Operation Plunder had begun. Behind the front lines, thousands of engineers waited with pre-assembled Bailey sections. As soon as the first assault boats reached the far bank, bridging columns moved in. Bulldozers leveled the banks while cranes swung prefabricated panels into place. The scale was staggering. Each bridge span required hundreds of panels, transoms, and decking units. Every component was manually handled, no automation, no shortcuts. Teams worked in rotation, driving pins with sledgehammers, aligning girders by hand. Floodlights turned the riverbanks into glowing industrial yards. The sound of metal echoed across the night. By dawn, the first Bailey Bridge was complete. A 1,140-foot Class 40 span, capable of carrying Shermans and artillery. Within 24 hours, multiple crossings followed. The Rhine, once thought impregnable, had been breached in multiple places. The speed shocked the German defenders. They had expected to hold for weeks. Instead, Allied divisions were streaming across in less than 2 days. Reports from the German 1st Parachute Army described the situation as untenable.
One officer wrote bitterly, "The enemy builds bridges faster than we can aim our guns." American engineers on the Southern Front achieved similar feats. The 150th Engineer Combat Battalion built a 1,080-foot Bailey Bridge across the Rhine at Mainz in 36 hours, working under constant artillery fire and Luftwaffe strafing runs. Every few minutes, explosions forced them to take cover. Then they simply stood up and kept building. One young officer described the moment a direct hit killed 3 men beside him. He wrote later, "The bridge had to go up. That was the only thought in our heads. Every man knew that what we built wasn't just steel. It was the road home." By the end of March, more than 20 dozen Bailey bridges spanned the Rhine, carrying entire armies eastward. General Montgomery, watching one of the bridges go up, called it the single greatest engineering achievement of this war. The numbers tell the story. Over 300,000 men, 50,000 vehicles, and thousands of tons of ammunition crossed into Germany in just days, largely on Bailey bridges. The Germans' last defense had fallen not only to firepower, but to ingenuity. For the first time since Napoleon, foreign armies were marching on German soil. But this time, they were doing it on bridges made by soldiers who could turn rivers into roads overnight. The Bailey Bridge was now more than an invention. It was a symbol of Allied momentum, of unbreakable logistics, of the quiet hands that made victory possible. As Patton's Third Army surged east, his engineers dismantled bridges behind them and reassembled them ahead. Like a mechanical tide, they carried the army forward. The Germans had tanks, artillery, and courage, but they were fighting an enemy who could erase natural barriers with bolts and pins. By April, as the Allies converged on the Elbe and the war neared the end, the message was clear. The rivers of Europe no longer belonged to the defenders. They belonged to the builders.
By late April 1945, the German war machine was collapsing from within. The bridges that once protected its heartland now served as the very highways of its defeat. From the Rhine to the Weser, from the Elbe to the Danube, Bailey bridges spanned every major river the Allied armies encountered. The statistics were astonishing. Between June 1944 and May 1945, Allied engineers constructed more than 3,000 Bailey bridges across Europe. In France alone, over 70 miles of Bailey roadway had been laid down. What had begun as a British innovation for quick mobility in North Africa had become the defining logistical backbone of the European campaign. American reports from the field painted a picture of constant, almost mechanical momentum. A single engineer company could construct a 200-foot bridge in under 10 hours. Entire battalions specialized in river crossings, their schedules as precise as a factory assembly line. Each man knew his part: pin driver, panel hauler, decking layer, crane operator. In the days following the Rhine crossings, the scale of the Allied advance was unprecedented. Infantry divisions that once crawled forward by miles per week now advanced dozens of miles per day. Supply trucks roared across freshly built Bailey spans, delivering food, ammunition, and fuel. German forces, fragmented and exhausted, could barely keep pace with their retreat. Their own engineers, short on materials, fuel, and time, struggled to destroy bridges fast enough to slow the advance. The Allies simply replaced each one, sometimes within hours. A German staff report dated April 10, 1945, captured the growing despair. Every attempt to delay the Anglo-American movement is rendered useless by their technical means. Bridges destroyed in the morning reappear by evening. The enemy seems to defy both nature and our efforts. Even rivers that had once been considered natural barriers, The Ruhr, the Saar, the Elbe ceased to hold meaning. Commanders no longer planned defensives around rivers, they planned through them. The Bailey had erased geography from the tactical equation. At Remagen, where the Ludendorff Bridge had finally collapsed into the Rhine, engineers wasted no time. Within days, they had erected multiple pontoon and Bailey bridges alongside the wreckage. What the Germans thought would halt the Allied spearhead for weeks instead delayed it for less than 2 days. Everywhere, the same pattern repeated. In northern Germany, near Osnabrück, British sappers constructed a 500-foot Bailey across the Ems River in 48 hours, despite mines and sniper fire. In the south, near Ulm, American engineers bridged the Danube while under Luftwaffe attack, losing men but never momentum. The phrase Bailey Bridge had become synonymous with forward motion, a moving front line of steel. War correspondents were quick to notice. Ernest Hemingway, reporting from the European theater, called the engineers the silent victors of the campaign. Other journalists described the spectacle of a bridge rising from chaos, hundreds of soldiers working wordlessly, floodlights glinting off steel, the air thick with smoke and rain. For the Allied troops who crossed them, these bridges became more than infrastructure. They were symbols of inevitability. Soldiers recalled the strange comfort of seeing a Bailey across a river, knowing that wherever it stood, the enemy's defense was already broken. As April turned to May, the rivers that had once divided Europe were now pathways converging on Berlin. By the time Hitler took his life in his bunker on April 30th, Allied engineers were still at work, building bridges east of the Elbe for post-war occupation routes. In a sense, their war never ended when the shooting stopped. The same structures that had carried tanks into battle would soon carry relief supplies, refugees, and rebuilding materials. The Bailey Bridge had not just conquered rivers, it had rebuilt them into roads of peace. Its impact would echo far beyond the war itself, in Korea, Vietnam, and even civilian reconstruction projects across Europe and Asia. But in 1945, as German resistance faded into silence, those bridges stood as the final proof that industrial ingenuity and soldierly persistence could overcome even the hardest laws of nature. The rivers had fallen quiet, but over them steel still sang, the echo of victory, built piece by piece. In the days that followed Germany's surrender on May 8, 1945, Europe was unrecognizable. Cities lay in ruins, bridges collapsed into rivers, and rail lines twisted across the landscape like broken spines. Yet among the devastation, one structure seemed to rise above the chaos, the unmistakable trusswork of Bailey bridges, stretching across shattered rivers, carrying not tanks now, but trucks of bread, medicine, and displaced civilians. The very same bridges that had delivered destruction now carried recovery. Military engineers, once trained for rapid assault, found themselves transformed into architects of peace. In France, Belgium, and the Netherlands, Bailey bridges became lifelines to reconnect towns separated by months of warfare. Photographs from the period show smiling children walking across steel panels where only weeks earlier artillery had thundered. British engineer battalions stayed behind to assist in reconstruction, often collaborating with local workers to rebuild permanent crossings. Some Bailey bridges remained in place for decades, long after the war ended, their riveted frames becoming part of the civilian landscape. For the German people, these bridges were a haunting symbol. The ingenuity that had once conquered them was now helping them survive. Reports from the Allied Control Commission noted that many rural communities in Germany relied almost entirely on Bailey bridges for transport and trade during the first post-war years. General Omar Bradley later remarked that without the Bailey, our advance would have been measured not in miles per day, but weeks per river. Eisenhower echoed the sentiment in his post-war reflections, describing the bridge as a weapon of victory as decisive as the tank or the airplane. Even German officers, once dismissive of the Allied approach to logistics, came to admire it. In post-war interrogations, several Wehrmacht engineers admitted that they had underestimated the Anglo-American capacity for construction under fire. One noted bitterly, "We destroyed everything, and still they crossed. Always they crossed." The bridge's influence extended beyond Europe. As Allied forces redeployed across the globe, Bailey components found new life in Asia, Africa, and the Pacific. During the Korean War, engineers rebuilt the same modular bridges to cross frozen rivers. In Vietnam, American forces again relied on them to navigate the deltas and jungle waterways. Each new conflict confirmed the same truth. The Bailey Bridge had changed not just the course of World War II, but the entire nature of military mobility. By the early 1950s, civilian industries had begun adapting its design principles for emergency construction and disaster relief. When floods struck Holland in 1953, Bailey spans were rushed in to restore transport. When earthquakes hit Italy and Japan, the same modular systems provided instant lifelines. Donald Bailey, the modest British engineer who had sketched the design on his kitchen table in 1936, was knighted in 1946 for his contribution to victory. When reporters asked him how it felt to have his invention called the bridge that won the war, he replied simply, "It wasn't me. It was the men who built it, in mud, in rain, and under fire." For the soldiers who had assembled those bridges, there was pride mixed with grief. Many remembered the faces of comrades lost beside rivers, men who never crossed the structures they helped raise. Military archives are filled with letters home from engineers describing nights spent knee-deep in freezing water, working by lantern light as shells exploded upstream. Yet even in those grim memories, there was something enduring, a sense that what they built had meaning beyond destruction. When Europe began to heal, the Bailey Bridge stood as both a relic of war and a promise of recovery. Its clean, functional lines came to symbolize a world learning, once again, how to connect. The guns had fallen silent, but the bridges remained, linking former enemies, binding a broken continent together one river at a time. In the great story of World War II, some victories were written in smoke and fire, in the thunder of tanks and the roar of aircraft, but others were written in silence, in the clang of steel, the turn of a wrench, and the echo of a hammer on cold metal by the side of a dark river. The Bailey Bridge was one of those quiet victories. It did not carry glory in the way a tank or bomber did. It did not fire or fly or explode, yet without it, none of those could have reached their battles. It was the skeleton of Allied momentum, invisible to most, indispensable to all. It embodied the essence of industrial warfare, flexibility, efficiency, and human persistence. It showed that wars are not won only by those who fight at the front, but also by those who build behind it. The bridge was not just steel and pins, it was trust. Trust that every soldier could depend on what lay beneath his feet, even under fire. In every campaign, across every river, the Bailey's presence told a quiet story. That ingenuity could overcome geography, that determination could conquer destruction, that progress, when driven by purpose, could outlast even war itself. When Germany fell and peace returned, those same bridges continued to serve. For decades, farmers, school children, and travelers crossed them daily, unaware that they were walking across the same paths where history once turned. And perhaps that is the truest legacy of the Bailey Bridge. Not the victories it made possible, but the connections it restored afterwards. From Normandy to the Rhine, from ruin to reconstruction, it stood as a symbol of how human invention could bridge more than rivers. It could bridge eras, nations, and wounds. The soldiers who built them may be gone, but their work endures, in steel, in memory, and in every quiet crossing that still spans the rivers of Europe today.